Good day everyone, my name is Rusty May and I am here to discuss and to show to you the D-Latch logic diagram that can be found in this link, and let's get right to it. So let's open the link. It's a link that goes directly to the logically.demo./samples, and it says here it's a digital logic simulator, and these are one of the following sample documents that we're gonna discuss to you, and it's called the D-Latch. The D-Latch acts as a primitive memory cell by storing data when the clock is high. Question: what are the logic gates you can see in the D-Latch simulator? As you can see, there's the diagram. There's two light bulbs, and in the left side of the simulator there's input controls, output controls, and logic gates, and these are the controls that you're gonna put here when you try to assemble a diagram out of these controls. Now in the question, I can see that in the D-Latch there is two AND gates, two NOR gates, and a toggle switch and a clock. These are important things to connect or to assemble in the D-Latch system. Next question: what is the initial setup? The initial setup is the D-Latch has a signal from the switch. It is stored when the clock is high. It acts as a primitive memory cell, as like I've said, by storing data when the clock is high. There's a toggle switch, and also there's a clock. So when you see the screen, the clock is blinking on and off, which means it is effective and it is on all the time. So when you on the switch, the upper light bulb ons. So let's see the next question. The next question is, what will happen if the switch is on? Like I've said, if you on the on switch, the light bulb is already on. It will send a signal to the upper light bulb. Next question: explain the analogy of events. The D-latches can be used as 1-bit memory circuits, storing either a high or low state when disabled, and reading new data from the D input when enabled. So that's the questions that I have answered, and that is all the assembled and the D-Latch I have discussed. Thank you and good day. Again, my name is Rusty May and I'm here to discuss the 1-bit full adder. And as you can see here in our link, it's the same link that we have done in the D-Latch. Now let's do the 1-bit full adder. The 1-bit full adder is a full adder adds two 1-bit inputs plus a carry bit. It outputs the sum. The second output is a carry bit that can be changed to another full adder. So let's click on it. As you can see here, there are three switches, two light bulbs, and there's also the same logic gates that we have seen in D-Latch. There's AND gate and XOR gate and OR gate. Now the first question: what switches that will make the sum bulb light? Analyze and explain the flow. So as you toggle the switch A, you can see that the light bulb ons on the sum, and it connects and it creates a signal to the sum light bulb. It is connected to the XOR gate and the two AND gates, and lastly the sum light bulb. Next question: what switches that will turn on the carry out bulb, and why does it need a combination? As you have seen, this is a combinational circuit. If you toggle switch A and B, it connects the XOR gate and AND gate with the OR gate. It is a combinational circuit, like I said, that adds 2 bits and carry and outputs a sum bit and a carry bit. The full adder adds the bits A and B and the carry from the previous column called the carry in, and the outputs the sum bit as sum, and the carry bit called the carry out is called this one. The variable s gives the value of the least significant bit of the sum. The variable cout gives the output carry. So that is the basic discussion that you can see that if you toggle switch A and B, the carry out will just on. The carry out bulb will just on. Now next question, what will happen if all the switches is on? Since this is the last switch, let's turn it on. All of the light bulbs is now on, and the carry out and the sum switches on with the same signal, with the same circuit that's been connected with the XOR gate and the AND gates and the AND gates. Then it will create the two light bulbs to on. And that's all for my discussion for today, and thank you for listening, and I hope you learned something from this simulator, the logic gates and the D-Latch and the 1-bit full adder. Thank you.
毎日同じことの繰り返しそんな日あることで嘘ばかり重ねてく怖い笑いはもう聞き飽きたこれが